Hey guys, and welcome back to another video. Today we'll be talking about parent functions that you'll probably be learning in Algebra 2. There could be a couple that I missed that you learned, but I'm pretty sure these are the ones that you're supposed to learn. So here I just drew a little graph. And so parent functions are basically just the functions, if you know f of x, and those are functions like we know how the linear equation is f of x equals to x, but like the y-intercept form is also this linear parent function, but it's just like the way you can add numbers in front, like it's mx plus b, because b is the y-intercept and m is the number that you can add in front of x. But a function is f of x, that's why it's f. We're gonna learn them today. For example, the one that I have here right now, f of x. The line would look like this because basically the way the slope does it, it's like it goes up each one slope each time or something like that. That's how that one is. So that's what f of x equals fx would look like. And it is called a linear function. You don't have to include the word function, but yeah. So basically, this is parent function, this is a linear. So the next one we have is an absolute value function. So if we know what an absolute value is, it is where we have these two lines with a number inside, and those two lines would make the number automatically a positive. So if we have 3 here, it would equal 3. But let's say we have -3 inside the absolute value, then it would become 3 because we're changing the negative into a positive. So that's what an absolute value is. And the equation should usually look something like this. Well, here's the written form first. It would be f of x is equal to absolute value of x, and then the line would be a v. And you can remember this by seeing that in the name of this parent function, absolute value has a v in it, and it's going to be the only function that has the letter b, so we can remember that absolute value is b. And this is one of the only like 2 or 3 that actually has a straight line, basically like a straight line, even though it's slanted, but it's still considered a straight line. So, and we know that absolute value, it's these lines, these straight lines in between. And so we can remember that that's what this one looks like. So that's an absolute value function. The next function is called a quadratic. You probably know about this one from Algebra 1 if we remember learning the parabolas. So that's what a quadratic is. It's basically a parabola. And so the equation would be f of x is equal to x squared. And as we remember, like the equation of a quadratic, when we put it into a graph, not the quadratic formula, but it would be like y equals ax squared plus b x plus c, and we'll get into that in another video, but just saying that's like where we can see x squared there, and that's what like the quadratic would be, and like a, b, and c determines like what and where the parabola will be. So the quadratic would be here. And also every parent function would also have a default of where it is. So we'll talk about how we can transform the parent functions in the next video. But each one would have a default position, and then from changing the default equation, we're able to transform it. And we will talk about that in the next video. So yeah, and then a quadratic should look something like this. The default one should hit the origin right there, so it should look like that. The next one is a square root function, and the equation should look like this. It should have the square root symbol in the equation, and it would look something like this. It starts at the origin, and then it would go to the right, and it would look something like that. And here we can remember this because this would be only half of the cube root, and it's kind of like this. Kind of looks like a noodle. It's kind of like, so basically half of the quadratic, but like tilted 90 degrees to the to clockwise, tilted 90 degrees clockwise. It's kind of because we can see a quadratic is here, and then erase like this side, right? So then we only have this side, and then make it 90 degrees, go 90 degrees, or rotate it 90 degrees clockwise, and then it would become square root, because a quadratic is x squared. So square root is opposite of the square. So yeah, and that's basically kind of going to be the same thing for cube root too. So move on. So this is what a square root should look like. The next one we have is a cubic. It's called cubic, and this is basically a quadratic, but it's cubed. So quadratic is x squared, but a cubic is x to the x cubed. So this equation, you can probably tell, is going to be f of x is equal to x cubed. So that's what the cubic equation kind of looks like. I probably didn't draw it accurate enough, but it should kind of look like that. Like, it does touch the origin, and it's kind of like a noodle. Not really sure how you can remember this, but I guess just remember it. It's like a noodle, so cubic is kind of like a noodle. But once you remember like one of the roots, square root, cubic, and then you can remember how they're kind of related because their equations are related. This is what a cubic looks like. The next one is cube root. Again, it's like the relationship that quadratic and square root has, and cube root is like the brother of cubic. So this equation will be f of x is equal to cube root of x. I get mixed up with verbally saying cube root or square root, but always remember to write it just in case you get mixed up of doing that math. So, and then this graph would basically be the other half of a square root. So if we remember, a square root was like this, and then if we add the other half on the other side, then that's what a cube root is. So basically like a sideways noodle. So if you remember cubic is a noodle, then cube root is also a noodle because it's cube. They both have 3. And then we know that it would be on the side, and this quadratic number 1 has the top, and quadratic 3 has the bottom. We can remember that because we know cubic is a noodle, and then we also know cube root would be the other half of square root. I think that's how you can remember it, unless you're really smart and you're able to remember everything. That's awesome. Organic chemistry tutor has found his lost son or daughter. Not being sexist, guys. So next one would be reciprocal. Reciprocal or inverse is what you can call this. If you can't remember what reciprocal means, you can call it inverse, but reciprocal is basically the opposite of a number. So basically, if we have another number 2, the reciprocal would be 1 over 2, because technically 2 is 2 over 1. Now that's the opposite, so yeah. So this function would be f of x is equal to 1 over x. And of course we remember that because doing a reciprocal would change it into a fraction, or change fraction into a whole number. So that's how we remember that. And the reciprocal should look something like this. So basically it's like, kind of makes it like an x, but it doesn't touch the origin, but it like goes around it and then like touches like the rest of the graph here. And it does go on both sides. This equation, the reciprocal, and the ones that I'm gonna show you guys, I don't think you'll it's not gonna be big on Algebra 2, but you probably do need to know it. So this one is a reciprocal. The next one is a rational. This one is going to be f of x is equal to 1 over x squared. So basically a reciprocal, but with the squared on the x. So this equation should look like, yeah, basically just like the reciprocal or inverse equation, except the two lines are side by side instead of opposite. And then you can remember that they both always start on the first quadratic. And so if a reciprocal has 1 on the first quadratic, and we know that the other line would be on the opposite quadrant, so then we would know it would be on 3. But since a rational should be side by side, and we also know that it starts at 1, so then we would know that the next one would be on quadrant 2. So that's a rational. The next one is this. I'm not really sure how to pronounce it because I didn't really learn it that much, but I think we can just call it log. So this one's going to be f of x is equal to ln to the power of x. I don't think that this one will be that important, but here's what the graph should probably look like. It does, like, just like the rational and reciprocal, it has, like, it touches it here at the bottom, touches, like, the whole line. So that's the log graph. And then the last one is called an exponential graph. So this equation is going to look like this. F of x is equal to e to the power of x. So we can remember this by the name. Exponential has the letter e. So e to the power of x. These last two are to the power of x. These are going to be probably the harder ones to remember, but this graph should look like this. Kind of like the log one, but on the other side. So the log one was like kind of like down here. So the exponential is kind of the opposite of log. And so that's an exponential graph. And those are the graphs that you need to know for parent functions. And the last like 4 graphs, you won't need to know that much on knowing how to transform these graphs, which I'm going to show you guys on the next video. But yeah, that's the video. Thank you for watching.